There was a long, sustained pause in the boardroom. Everyone was in deep thought, trying to put the pieces back together, including me. Finally, the head sighed and said, "All right, let's look at the film again. We were on the Presidential Commission on the Space Shuttle Challenger accident, and we had the brutal assignment of investigating the accident and figuring out why the Space Shuttle Challenger crashed. At the moment, we weren't accomplishing our goal. We didn't know why such an accident would happen." The Space Transportation System Challenger, or STS, was the epitome of technology. Unlike rockets before it with only one stage, the STS had three. The fuel tank supplied the tons of liquid hydrogen and liquid oxygen to the solid rocket boosters. Two solid rocket boosters accelerated the shuttle out of the atmosphere. Last, the orbiter was the main component holding the cargo and team of astronauts. This $6.7 billion project was composed of 2.5 million parts and 230 miles of wire. More than 27,000 heat-insulating tiles protected the shuttle from temperatures ranging from -250 degrees Fahrenheit in space to 3,000 degrees Fahrenheit when entering the atmosphere. The craft could pump 44 million horsepower and exceed speeds of 17,400 miles per hour. The shuttle was 4.5 million pounds. 3.5 million of these pounds went to propellants, which were burned off at a rate of 10 tons per second. But the most important part of the Challenger was that it was reusable. Rockets in the past weren't, and cost NASA countless amounts of money, and the refurbishment of the shuttle made it the most cutting-edge technology ever. "So why did it explode?" a colleague asked. I said, "Let's review from the beginning, prior to launch." At the Kennedy Space Center launch pad in Cape Canaveral, Florida, NASA would launch 7 astronauts into space. The astronauts were Francis Scobie, Michael Smith, Gregory Jarvis, Krista McAuliffe, Judith Resnick, Ellison Onizuka, and Ronald McNair. NASA named the mission Challenger STS-51L, and it was to be their 25th mission and their 10th with the Shuttle Challenger. With 9 previous missions, the launch must have felt like routine for NASA. The crew would have the task of placing 2 satellites into orbit. One was the Tracking Data Relay Satellite 2, a communication satellite. The other was the Spartan satellite, which would observe Halley's Comet. This mission was scheduled for July 1985, but payload changes and weather issues bumped back the date. The launch date was finally set for January 20, 1986.
SRB hydraulic power units have started. T-minus 21 seconds, and the solid rocket booster engine gimbal now underway. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Control program. Roger, roll, Challenger. Good roll program confirmed. Challenger now heading downrange. Engines beginning throttling down now at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%. 3 engines running normally. 3 good fuel cells. 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3 nautical miles.
So the 25th Space Shuttle mission is now on the way after more delays than NASA cares to count. This morning it looked as though they were not going to be able to get off.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
Looks like a couple of the solid rocket boosters blew away from the side of the shuttle. in an explosion.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Estimated flight time was about 74 seconds, I said. Pause right there and look at the right solid rocket booster. The head said, I see it. It looks as if the O-ring became loose after their throttle went up. That could lead to a gas leak and ignition of the fuel tank. Piecing it together, the commission discovered that the seal on the O-ring failed. But rather than actually exploding, the fuel tank's propellants rapidly burned and the orbiter became demolished by aerodynamic stresses. NASA must not have been aware of the recent problems with the O-ring. It broke due to temperatures under 53 degrees Fahrenheit, physical dimensions, the character of materials, and ice on the launch pad. It was too cold a day to launch, and, because of NASA's wrong judgment, 7 astronauts died that day. They should shut down NASA, someone suggested. That's unnecessary. NASA is too important to this country, I said. Instead, NASA should postpone all missions until safety improvements are made. For 2 years, missions were postponed until 1988. During that time, many safety requirements were made, including more restrictive conditions for launching, the Challenger not being used for launching commercial satellites anymore, and improved on the O-ring design. NASA even made a bailout system. Although it didn't work in all cases, it could save lives. The Challenger was replaced with the Orbiter Discovery, which continued many more, safer missions. The Challenger, even though it was America's greatest technology, fell from the smallest hiccup. The Presidential Commission on the Space Shuttle Challenger accident finally adjourned.